So 4.12, I'm going to go over the calculator steps. A part isn't necessarily a calculator step, so I'm not going to spend a whole lot of time on it, but it does ask you which of the models, the power law or the exponential model, is more appropriate. And again, just like I said in 4.6, this is difficult to tell just with your eye. I do want to mention that this is talked about on page 280 of your text. It's some algebra knowledge, and because we're dealing with the physical quantities between the relationship between diameter and surface area, we can assume, keep that in mind, that we're assuming that the power law makes a better model, but technically we would have to go through all the steps and look at the residuals of both models. But we will go ahead and say that the power law is probably more appropriate here. In B part, you need to go ahead and start to, let's see, construct the model for the data. So what we need to do is put our data in list 1 and list 2 when we construct the model. So we're putting the diameter in list 1 and the cost in list 2. Now, because we're doing a power law model, we take the log of both the x and the y. Remember, with exponential, we only take the log of the y. So to take the log of the x and the y, we're going to go over to list 3 and then take log of list 1. So we took the log of the x. Now I'm going to highlight list 4 and take the log of list 2. And then I have the log of the x and the y. So then what I want to do from here is I want to go to my main screen, and I'm going to hit, or I'm going to try to find my linear regression. So I'm going to go to Stat, Calc. I always choose number 8 because I like that it puts the a plus bx instead of b plus ax. And then this time, keep in mind, we're doing the power law model, so we need to do list 3, comma, list 4, because we need the logs, not the original x and y. And then I want it to store in y equals. Now, I already made sure my y equals screen was clear, so make sure you do that. Vars, y vars, function, y1, and it'll store this equation in our y equals screen. Okay, so this is our log of y hat equation. Now your book sometimes mistakenly just puts log of y, it's log of y hat. And then if you go to your y equals screen, it's stored there now. And the way now we can see, and I should have actually graphed, I apologize girls, I should have graphed the original just to make sure it looked curved, but I did not do that for you here. But now we could graph the L3 and L4 and see what that looks like. We could see if it appears to be straight. So I'm going to graph L3 and L4. I'm graphing the transform data in Zoom Stat. Always use Zoom Stat in statistics. And it appears to be straight, but we're not quite sure that this is an appropriate model for our data because we haven't graphed the residuals, and we'll do that in a second just to double check, but it does appear that it has gotten more straight. Now I would again encourage you to graph the original data before you do this part. So then we're asked to do the back transformation. Well, I've provided that answer for you if you were to do it algebraically on paper, but on your calculator you need to say, now remember the back transformation, or the inverse transformation as your book calls it, is 10 raised to the a, x raised to the b. So we're going to put parentheses here, 10 raised to the vars. Okay, girls, pay attention because this is a lot of steps. So we go to vars, and then we scroll down to statistics, and then we go over to equation, and then we go to a, close parentheses, x right here, raised to the same thing, vars. Basically in statistics you use stat, vars, or some variation of those stat, second stat or second vars. But anyways, vars, statistics, equation and B. And that is our back transformation. So we've stored this in our y sub 2 screen, okay? And then that formula, or written out, would be our back transformation, inverse transformation, would look like so, okay? So let's go back to our calculator, and now that we've stored that there, I did promise that we would do our residuals. So let's go back and look at our residuals. So I'm going to go to stat plot, and for our residuals, now remember when we did our exponential model, this was L1, but that's because our x's don't change with the exponential model. Our x's change because we take the log of them with the power law model, and remember those are stored in L3. And then remember your shortcut for residuals is to say second stat, go down to resid, store that there, zoom stat. And looking at our residuals, remember we hope that there's not a clear pattern in order to say that our least squares regression, or our linear regression model, I should say linear regression model, is, in order to say that our linear regression model is appropriate, we have to see that there's no clear pattern in the residuals, and we don't see that there's a clear pattern here. Again, if you were to graph this on paper, you would go to window and check out your windows here. So this was part of your C part. The next step for your C part is to go to your home screen. Again, I apologize. And because we're asked if would we advise the manager to adjust the price of the pizza slices. So using our inverse transformation or back transformation, we're going to go to vars, y vars function, and y2, because remember that's where our back transformation is stored, and we're going to plug in those values. So if you plug in the diameter of 10, you get $4.01, which that's pretty close to the original $4. And then if we do the same thing and plug in 12, you get $5.90, which is really close to the $6. And then you would do the same thing for the 14-inch and the 18-inch, and you would see that all the values are fairly close. There's only slight differences, so adjusting the price is probably not necessary here. So that would be your C part. D part asks you to make a prediction of a 24-inch party pizza. So we would do the same thing, but we would plug in a 24-inch pizza, and we could make the prediction that that would cost $25.55. And then finally, the last step says to suggest an alternative model to one that you calculated in B by performing a transformation that does not involve logarithms. Well, some of you may know from Algebra 1 that sometimes you can transform your data or make them more linear by taking the square root of that data. So I'm just going to look and see what that might do to my data, just out of curiosity. Whoops, stat, edit, and we don't have anything to list 5. So what I'm going to do, just like in exponential models where we transform the y, I'm going to transform the y variable here by taking the square root of it. So I'm going to say square root of list 2. Okay, and then I'm going to see what that does to our data. So I took the square root of it here. So I'm going to go to my stat plot, and just like with exponential, this is L1, and then I did L5, and then zoom stat. And that looks, oh, and girls, big, I've said it before, rookie mistake. I didn't clear out my y equals screen. So that's why that line's showing up. It looks fairly straight, but I'm not positive. So what we would have to do is go through all the same steps that we go through with any of our models. So I'm about to stop here because we've already gone through those steps both with the exponential and the power law, but what you would need to do from here is again do your transformation. So you would need to go to Stat Calc number 8, and actually I'll go ahead and start setting it up for you. L1, and we did our transformation in L5 because we didn't transform the X. That's why we're still using L1. And we're going to store it in, you should be getting faster at this, in your Y1. That would be your equation. So that's stored in your Y1. And then to back transform, the opposite of the square root is to square it. So vars, y vars, function y1, and then square it. And then from there we could, and again you would want to look at the residuals, so just to make sure there's no clear pattern. But then you could say vars, y vars, function y2, and then we want to plug in a 24-inch pizza, and we would make the prediction that it would cost $25.28. So it's still pretty close, but again, the one part I left out was to do the residuals and make sure there's no clear pattern here. I hope this helps. Let me know if you have questions.